Hey everyone, today we're going to work on some sonar. And the first thing we want to do is take a look at, well, how does sonar really work? Like, what are we trying to do? The basic system is this. You'll have two different transducers. A transducer is just something that takes either a mechanical function and turns it into a voltage, or a voltage and turns it into a mechanical function. So in the case of a speaker, right, we're going to put voltage into it and it'll flex a membrane, which will then create a pressure wave. Now, the pressure wave is more or less like this diagram. So as the membrane is flexed out, it'll create a high pressure area, and as the membrane is flexed in, it'll create a low pressure area. Now as you do this through time, you get periods of high pressure waves and low pressure waves, and this is what runs through the water. Now, so we'll create those pressure waves and they'll run through. We'll have blue here going to the left, it'll come hit an object and then reflect back, come back and hit a microphone. What we want to record is the time it takes for the pressure wave to cover that whole distance. So we'll take a time stamp, we'll take a time reading when we send out the pulse, and then we'll take a time reading when the pulse is received by the microphone. And then the basic equation for this is velocity times time will give us distance. So a sound wave goes through water at 1,484 meters per second. And we record the times, so if you multiply the velocity by the time, you'll get your distance. And then we'll have what our reading is. Now, a quick word of caution here. The device that I've designed and we're going to build today is only good up to about 4 inches. So it won't really be good for sonar for long distances, but it would give you an obstacle detection device. So just to get that clear, so let's head over and see what all the parts we need. So first off, we'll need some sort of speaker device, right? So this is a little piezo buzzer speaker. We will also need two film canisters. These are just regular film canisters. You can get them from like Walgreens. You can usually get them for free in the photo areas if you just ask for them. And piezo buzzer you can just get off of SparkFun or any kind of electronic supply. They usually cost about $1.50. Then we will need a microphone. You can either buy one from SparkFun that has the amplifier already built on this little breakout board, and then the microphone. So you can go that route, which is about $8, or you can buy the microphone for $1.50 and then build your own circuit here. So minus the breadboard, all of the components here cost about $2, and the microphone costs $1.50. So you can, save $3 or $4 by building it yourself and learn some things along the way, which I recommend. And so on the circuitry, you'll need 4 capacitors, which are on the parts list, and then you'll need some resistors and an operational amplifier and some leads. So that'll be the components required for the amplifier and the microphone. You'll need another film canister and some mineral oil to cover it all in. Then, as far as waterproofing it, you'll need some hot glue and a glue gun to set it all together. Lastly, you'll need some cable. Here, I've chosen to use coaxial cable. It's good because it's shielded and it has very good connections on it. Okay, so that's to build all of it. Now we'll also need to test it, to look at it, to power it. So there's 4 devices that we'll need to use to actually have this thing working. One, we'll need the stereo amplifier in order to increase the amplification of the signal we're going to send to the piezo buzzer. The signal will be given by this waveform generator. We'll also need 5-volt constant power supply. You can get that from a power supply or from battery. And then we'll also use LabVIEW, so this box and a computer software system, in order to record all of your times and power it all and look at what's going on. And that's all the parts that you'll need in order to work on this. Alright, so now we're going to talk about the design for a preamplifier. Now you can buy this already bought, and it's on the material list of an integrated amplifier onto your mic, and that's just fine. But you can also build one for way cheaper, and we're young engineers, so why not, right? Let's build it. So what we have here is the diagram for the circuit, and then here's the physical design that I put together. Now, big picture ideas here, what we want to recognize is wherever it says this VCC, that's going to go to our positive 5-volt on our power supply. So this VCC here corresponds to this line along our breadboard, this red line. That'll be our positive 5 volts. And then wherever it has ground, this will be our blue. Okay, these two blue lines running along our breadboard. So all this line is connected and all of the blue line is connected. Now on this inner part, talking about the breadboard here, all of these in line this way are connected together. And that's how we'll be able to put this into here in somewhat compact form. So now looking at this at kind of a map, I've worked it left to right and it follows here. So if you look at like this segment right here, that's right in here, and this segment below here, that's this capacitor and resistor right here. So you can kind of follow it in the same design as how it looks on the paper. But let's look into a little bit on some of the details here. The resistor, all the resistor symbols are these wavy lines, and then they have the rating here, 2.2 kilo ohms. The resistors are these little guys here, kind of these little circular oval kind of pieces. And then the capacitors are these two parallel bars. And the capacitors on this design is, these two here, and then this yellow one and this small one there. So these are our 4 capacitors on our circuit design. The other kind of different symbol here is this big triangle, and that's the operational amplifier. So you get your operational amplifier, and then you want to pull up its data sheet to find out which pins work where. So the physical operational amplifier is here, and it actually has 4 working op amps on it, or you could set up 4 of them on it at once, but we just need 1. So we're going to pick these 4 pins on the upper left side. So the signal coming in from the microphone, that'll go into our negative. And that is actually the 3rd pin. So 1, 2, the 3rd pin, right, this white is coming into there. And then the positive side, that's our 2nd pin. So our 2nd pin right here. And then the audio out is our 1st pin. So that's this 1st pin connecting to this orange one and then coming out. And then lastly, we have the positive 5 and our ground coming into the operational amplifier. Our positive 5 is this white coming into the 4th pin, and then this gray lead connects our ground to our operational amplifier. So you follow this through and you should end up with a design like this. And what you'll do is you'll connect your positive 5 voltage into the red and your ground into this black that connects both blue lines for our ground. And then this other little segment here that's kind of off of the whole thing, well, that's just a capacitor in between your positive 5 voltage and your ground, and that helps cut out on the noise that your microphone will be sending into your data collecting device. So here on the far left, these are your 2 leads for your mic, and then this line coming out here, this will go to your data collection device. So in our case, LabVIEW.